Hello everybody, this is Miss Pi again. This video I'm hoping to get done in less than 10 minutes since the bell's going to ring in exactly 10 minutes. It's going to be I'm going through pretty fast, and hopefully you can rewind it and watch it again if you need to. What we want to look at is our special right triangles from the couple units ago. We have the 30, 60, 90 triangle, and then the 45, 45, 90 triangle. With these triangles, it's special because our trig ratios, or sorry, not our trig ratios, but the, what am I thinking? Our side measurements are all going to be proportionate. So if our short leg is x, then the long leg is always going to be whatever x is times the square root of 3, and the hypotenuse is always 2x. And then with the 45, 45, 90, if one leg is x, the other leg is also x, and the hypotenuse is whatever x is times the square root of 2. Okay, so those are our special right triangles, and that is going to have an effect on what our trig ratios are. So this is a page in your notes. Find it in your notes, and let's go ahead and look at it. What we've been doing so far is finding the trig ratios when we have either a point that the rotation angle goes through, or if we have one trig ratio, if we have one trig ratio, we find the others. Well, with our special right triangles, we can find information even if we don't have other things. Like in this case, the only thing we know is that sine of 300, we can put that in the calculator and get an answer. And then we are supposed to come up, or I guess decide or find out what the ratio is. So if we look at this, the easiest thing to do is to first figure out exactly where 300 degrees is. Well, a rotation angle of 300 degrees puts us in our fourth quadrant. And notice that they've all of a sudden labeled everything. Okay, well, if our rotation angle is 300 degrees, that means our reference angle is going to be 60 degrees, and this is our 90-degree angle, so this angle here is 30, and guess what? We now have a special right triangle. So if I label my x, my short side 1, then that makes the hypotenuse 2 and the long side square root of 3. But notice I have a negative here. It's negative because I'm in the fourth quadrant. Okay, so my side values will be 1 square root of 3, and 2, my reference angle is my reference angle is 60 degrees, and then the trig ratio for sine of 300 is just going to be negative square root of 3 over 2. Now I know when you put this in the calculator did not give you this nice, neat, exact answer. It gave you a decimal, and there's really not a lot you can do with that decimal. But we can do all this stuff even without a calculator. Okay? I cannot tell you how important it is to draw a picture when you guys are doing this. Let's look at our next example. We want to find secant of negative 5 pi over 4. That's a radiant value. And for most of you, it will help if you convert that into degrees. So we have 5 pi over 4. We are dividing it by pi and multiplying it by 180. So pi is going to disappear. 180 and divided by 4, that's going to be reduced. Let me try to do this in my head. I'm not having a very good luck. I'll probably have to write it down somewhere. But luckily I have the information already done for you. So real quick, the 5 pi over 4 ends up being like what, 180 plus another 45. What, 225? Okay. Yeah, I think it is 225. Anyway, so the reference angle, the rotation angle is negative 225. The negative comes from our negative sign here. So we're going clockwise instead of counterclockwise. The reference angle, though, is just 45 degrees. If this is 45 degrees, then guess what? This angle is 45 degrees too. This is our right angle. And we have a 45, 45, 90 degree angle. With that being said, I'm going to make this side value -1 and this side value +1. Okay, it's -1 because it's going to the left, and this is +1 because it's going up, which means that because this is a special right triangle, our hypotenuse will be square root of 2. Well, secant is the ratio of, let's see, what's the ratio? Secant is the reciprocal of cosine, so it's going to be r over x, right? X is -1, r is square root of 2, so it just becomes the square root of 2. All right. So for this example, they want us to find all the trig ratios, and so our x is -1, y is 1, and r is square root of 2. We can set up our ratios, and we get this information. Okay, I know that we've done this a million times by now, so I'm just showing you the answers. If you were confused or you didn't know how to get rid of the square root in the denominator, there's several examples here and here. If you were confused about what the ratio would be or how to set it up, there's examples, okay? Go through it, study it as much as you want. I'm going to move on. Pause it if you need to. All right, last example here. Last example, we have sine of 3 pi over 2. I believe that's going to be 270 degrees, and that you end up being on the negative y-axis. Yep, you have negative y-axis. And notice we don't have a triangle, but let's pretend that we did. For some reason, it's some weird triangle. And the formula would be the square root of x squared, which is 0 squared, plus -1 squared. Okay, we can still plug those values in. We end up just getting 1 here for our r value. Okay, and yes, I know that there's really not a triangle there. It's okay. So in this case, this situation is going to happen anytime you land on one of the axis points, one of the x or y axes. Okay, your r value will end up being 1. Either x or y is 0. The other one is going to be -1 or +1. And then what ends up happening is whatever your value is. If you're looking for sine, it's going to be -1. If you were looking for cosine, it would just be 0. You'll end up with some undefined terms as well. All right, so I think, oh, that's right. I forgot to tell you about why sometimes our angles do not work out. Yesterday in class, we talked about calculating or doing the inverse trig ratios. Hold on, there's the bell. I'll let it finish ringing. All right, so yesterday we talked about doing the inverse of the trig ratios to find the angles, and we found out that sometimes it works and sometimes it doesn't. And these are examples of why sometimes it works and sometimes it doesn't. Okay, so here you have two different rotation angles, but if you set up your trig ratios, you'll notice that for both of these, your sine values are exactly the same. So if I did inverse sine of 3 over 5, I would get only one angle. Okay, I would get this angle. I would not get this angle. Okay, and then over here, again, your ratios for cosine would be the same. Okay, and when I do the rotation angle or inverse sine or inverse cosine to find my angle, I would get this angle, but not this one. Okay, so that phenomenon happens a lot. Tomorrow, when you come into class, we will be filling out these tables and figuring out what's happening when we try to find the angles from the ratio. All right, so that's the end of the video. I hope you enjoyed it. I will see you in class tomorrow. Please, please, please remember to take notes and bring your notes to class or you will not get credit for watching the video. Okay, so I'm out of here. Bye.